Decomposition of a body. Can the bones survive 1 million years? The time it takes for a human skeleton to disintegrate depends on the environment and other factors and can range from a few years to hundreds of years. Fertile soil. In fertile soil, acids can dissolve a human skeleton in about 20 years. Neutral or sandy soil. In neutral pH soil or sand, a skeleton can remain intact for hundreds of years. Buried remains. Burial can slow decomposition because it blocks exposure to oxygen and other destructive agents. Microenvironment. The local context in which decomposition agents act on remains can drastically increase or slow the process. Temperature. The rate of chemical reactions in a cadaver doubles with each 10 degrees Celsius rise. Humidity. Water from the environment can slow the effects of chemical reactions. Acidity or alkalinity. Extreme acidity or alkalinity can hasten the rate of decomposition. Bones can also undergo fossilization, converting into minerals that may persist indefinitely. The time it takes for a human body to decompose depends on many factors, including the environment, whether the body is embalmed, and whether it's buried in a coffin. Decomposition stages. The body goes through several stages of decomposition, including internal organs decompose, 24 to 72 hours after death. Bloating, 3 to 5 days after death. Color change, 8-10 days after death. The body turns from green to red. Teeth and nails fall out, several weeks after death. Liquefaction, 1 month after death. Skeletonization, the final stage of decomposition, which can take 1 month to several years. Time to decompose in a coffin. On average, it takes 10 to 15 years for a body to decompose in a coffin to the point where only the skeleton remains. However, it may take several decades if the body is embalmed and in a sealed metal casket. Time to decompose without a coffin. A body buried without a coffin typically skeletonizes within 5 years. Time to decompose in an exposed location. In summer, a human body in an exposed location can be reduced to bones alone in just 9 days. Photo 1, 8 to 10 days after death. Photo 2, 1 month after death, depending on conditions. Photo 3, 5 years after death without a coffin. Can skeletal bones survive for millions of years? Bones can become fossils. Some bones do manage to achieve true immortality, and you've probably seen dozens of them in the course of your life, most likely in museums. Fossils are bones that were covered in sediment so quickly that the air was completely blocked out, making any decomposition impossible, as is the case after volcanic eruptions and other catastrophic events that displace large amounts of sediment in the earth. Only a tiny fraction of living organisms manage to become fossilized, and even then, we still call them bones. But that is not really the case. Fossils were bones that never decomposed. But over time, minerals in the surrounding materials began to leach out of the living tissue and replace living cells with rocks. So when we talk about dinosaur bones being excavated after millions of years, we are actually just digging up ancient rocks that are shaped exactly as the original bones once were. Finding Homo nearly 3 million years ago. The fossil record of humans is notoriously patchy and incomplete. Even so, skeletal remains and artifacts unearthed in Africa in recent decades have done much to illuminate human evolution. But what is the origin of the genus Homo? Vilmore et al. Found a fossil mandible and teeth from the Afar region in Ethiopia. The find extends the record of recognizable Homo by at least 500,000 years to almost 2.8 million years ago. The morphological traits of the fossil align more closely with Homo than with any other hominid genus. DiMaggio et al. Confirmed the ancient date of the site and suggest that these early humans lived in a setting that was more open and arid than previously thought. The LD 350-1 Manda 2, the LD 350-1 mandible. A. Medial view. B. Lateral view. C. Occlusal view. Basal view. E. Enlarged occlusal view of dentition. Scale bars 1 centimeters. The geographic and geologic setting of the LD 351 hominin mandible. A. Map of the Leodoida region in the Ledi-Geraru research area. B. Stratigraphic section of the Leodoida sequence indicating the provenience of LD 350-1. C. The LD 350 locality, with the position of the LD 350-1 mandible on the surface in relation to the Grumaha tuff. Resistant ledges in the center of the photo are localized cemented sand and carbonate nodule pebble conglomerate. The section in B is indicated by the black line at left in C. Given its location and age, it is natural to ask whether the LD 350-1 mandible represents a late surviving population of A. afarensis, whose youngest known sample date to 3.0 May at the neighboring Hadar site. A. afarensis, nickname Lucy's species. Discovery date 1974 in Africa, Ethiopia, Kenya, Tanzania. When lived between about 3.85 and 2.95 million years ago. Height, males, average 4 feet 11 in, 151 centimeters. Females, average 3 feet 5 in, 105 centimeters. Weight, males, average 92 pounds, 42 kilograms. Females, average 64 pounds, 29 kilograms. Australopithecus afarensis is one of the longest-lived and best-known early human species. Paleoanthropologists have uncovered remains from more than 300 individuals, found between 3.85 and 2.95 million years ago in eastern Africa, Ethiopia, Kenya, Tanzania. This species survived for more than 900,000 years, which is over 4 times as long as our own species has been around. It is best known from the sites of Hadar, Ethiopia, Lucy, AL288-1 in the first family, AL333, Dikika, Ethiopia, Dikika child skeleton, and Laetoli, fossils of this species, plus the oldest documented bipedal footprint trails. What about animals? A dog's body can take several months or years to fully decompose after death. The time it takes depends on many factors. Burial depth. The deeper the grave, the slower the decomposition because there is less oxygen and fewer microbes. Soil conditions. The type of soil can affect how quickly a dog decomposes. Alkaline soil can help speed up decomposition. Size of the dog. Larger dogs take longer to decompose than smaller dogs. Temperature. Warmer temperatures speed up decomposition. Dinosaur bones. Dinosaur bones can last for hundreds of millions of years and become fossils. Dinosaur bones can become fossils through a process called permineralization, where minerals from water replace the organic material in the bone. The bones are then encased in sediment, like mud or volcanic ash, which turns to rock over time.